All right, first things first. You guys have a web assign, and I'm saying this on the recording so you know. Your web assign for this lesson, you need to do a PDF only. Because of the way some of the simplification occurs when we're eliminating the parameter, which is what we're doing today, it can be very sketchy on how you enter it. Some of you are going to enter it differently, and it's still equivalent. So for this web assign for 9.4, your web assign, you just need a PDF only. I didn't add any more questions or anything, just so you have it, okay? Now, what is the most important thing from today's lesson that you can take away from this? And I don't like the way I wrote this, so I'm going to write it prettier. But when the directions say, given the parametric equations, eliminate the parameter. What does that mean? This is the pre-calc part of it. Understanding what eliminating the parameter means. That means to get rid of t. What does it mean to eliminate? To get rid of, right? So if you are eliminating the parameter, eliminate, get rid of, the parameter is the t value. Yesterday I gave you the t values to use. You plugged it in to find your x and y, and then you graphed it. Today you're going to be given two parametric equations. You are going to have to eliminate the parameter and write them as rectangular. That's the pre-calc part of it, the instructions. The rest of it is all algebra. So here is a little, like a flow chart, if you will. These are parametric equations. How do you guys know that these are parametric? Because of the t. There's an x, there's a y, and there's a t. There's that third variable. So to go from parametric to rectangular, right? We're going from parametric to rectangular. What we have done is we've eliminated the t. So you're going to solve one equation for t. They chose to do this one because it's easier, right? We multiply both sides by 2, so you get t equals 2y. Then they took this 2y and plugged it in for the t. That's right here. And then you simplify. That's it. It's all algebra based. You could have solved the first example. You could have said, look, if you wanted to solve this one, how would we get t by itself? Well, you'd have to add 4 to both sides, right? So you have t squared equals x plus 4, and then do what? Take the square root. When you take the square root, guys, what goes in front of your answer? Plus or minus. So then you would have to take this value here and plug it in for t there. You'd get the same answer. That's fine. Not necessarily, it won't look the exact same as this one because obviously you're solving a different equation, but you'd get the equivalency. But I would always go with the one that looks easier, right? If you have a square root involved or a squared, I would always go to the other one because it's going to be easier. So here's examples. 2 examples. Take a picture of this one. I'm changing them. So here. So the question is going to say, given the parametric equations, eliminate the parameter. I'd say write as rectangular. What that means is get rid of the t. So first off, guys, you can solve whichever one you want for t. Which one looks easier? The first one, the x, okay? So how would you isolate the t? What would you do? Subtract 4, good. So you have x minus 4 equals negative 2t, and then divide both sides by negative 2. So t equals x minus 4 over negative 2. Guys, can you cancel out the negative 4 and the negative 2? No, because remember, x minus 4 is together. It has to go into both before you just start eliminating. So don't just make silly algebra mistakes. From this point on, guys, this is all algebra. Because what do I do with this? I take this value and I plug it in everywhere I see a what? A t in the other one. So now this just becomes algebra. Not even algebra 2, it's algebra 1. So as we go to solve this, you need to take your time and be careful. You have 3 plus 6. Instead of the t, I'm writing x minus 4 over negative 2, correct? Then I have minus 4, and instead of the t, I'm writing x minus 4 over negative 2, and then that's what? Squared, okay? So let's do some simplification here. This 6 on the outside, can I simplify anything there?
Negative 2 and 6.
Yeah, negative 2 goes into 6 how many times? Negative 3. So this becomes 3 minus 3 times x minus 4 minus, now, can I do anything here? Not yet. Why can't I? Because of the squared. What do I have to do with this squared? I have to distribute it to the top and to the bottom. So this becomes x minus 4 times x minus 4 over, what's negative 2 times negative 2? 4. Now, can I do some simplifying? Yes. The 4's cancel, correct? Does that negative go anywhere? No, it's still there. Don't forget it. So now we just keep simplifying. I have my 3 still hanging out here in the front. When I distribute this negative 3, what does this become?
Negative 3x.
Perfect. Perfect. I'm going to leave this minus here, and then I'm going to FOIL. What's x times x? X squared. Then I have x times negative 4. And a negative 4 times x is going to give me minus 8x. And then negative 4 is plus 16. Perfect. And then I have one more thing to do before I can fully simplify. I have to distribute that negative. So I have 3 minus 3x plus 12 minus x squared plus 8x minus 16. The hardest part about this, guys, is not understanding what eliminate the parameter means. It's, I hope I don't make a silly algebra mistake. The first step of understanding, okay, they're telling me to eliminate the parameter. That means I get t by itself. That means I take what I just solved and plug it into the other one. Then you go to algebra. So we have now y equals, what's my highest exponent? What do I write first?
X squared.
All right, so negative x squared, negative 3x and a positive 8x.
Plus 5x.
Plus 5x, and then I have 3 plus 12,
15.
minus 16,
Negative 1.
minus 1. Have we eliminated the parameter? Yes. What does it mean to eliminate the parameter? Get rid of t. Do I now have a rectangular equation? Yes, I have y's and x's. That's it.
You don't need to solve that?
Nope, you can just leave it right there. So on WebAssign, sometimes, like you'll see in the next one, there's different places you can stop solving, or you could maybe factor out a negative, that sort of a thing. That's why I don't want you to do it on WebAssign. As long as your algebra is fine, you're good. Yep.
I kind of miss when the t was gotten rid of.
Okay, up here. We solved this equation for the t. And then we plugged it into the other equation. All right, let's do the next one, and then we're done. Okay, now again, if you do not have to always, all of you solve for the same one. There's going to be 2 different answers. Oh, I forgot about my ashes. If some of you solve for x versus some of you solving for y, I'm going to work it out on the answer key both ways. But what would be the easier route to take? X, right? There's nothing squared or anything like that. So let's solve your x equation for t. I want to get t all by itself. So we're going to add 3. You guys agree? X plus 3 equals negative 2t, and then what? Divide by negative 2. So t equals x plus 3 over negative 2. Everybody understand where we got that? Now what do we do with that? We're going to take this and plug it into t in the other equation. Take your time. This is where silly mistakes will happen. We have 2 times, instead of t, what am I writing? X plus 3 over negative 2, and that's what? Squared. Okay, remember that squared means, gotta do it first. Plus 2 times x plus 3 over negative 2, and then what? Minus 5 over 2. Perfect. We always want to try to simplify, make things easier. If you want to say, oh, don't forget I have to distribute this first, go ahead. Do the distribution first. So you have 2. If you want to write over 1 there, that's fine. This just means x plus 3 times what? X plus 3. Perfect. And then what's negative 2 squared? 4. Right? What happens here with my 2 over 1 and then the negative 2 on the bottom? It's going to cancel and become a what? Negative 1. Good. So minus x plus 3. Look how I left it in the parentheses so I don't forget to do what with that negative sign? Distribute. Good. All right. Can I fully get rid of my denominator here? No. But can I simplify? Yeah. 2 goes into 2 once, 2 goes into 4 how many times? Twice. So I'm going to be left with x squared plus 6x plus 9. Where did I get that from? I foiled, okay? Then I have minus x minus 3 minus 5 over 2. What part can I continue to simplify? The 3 over 1. What can I change that to?
6 over 2.
I can change this to 6 over 2, correct. And then can I simplify that? Yeah. So x squared plus 6x plus 9 over 2 minus x minus 11 over 2. Now, somebody last period, what do you think they did? They didn't want any denominators. All right, I'm fine. I am fine if you guys left it right here. Somebody last period was like, I don't like having the denominator. Okay, fine. So then what would you change this denominator to?
A 2.
I would change this to a 2, and then this would become what?
2x.
So then you have x squared plus 6x plus 9 minus 2x minus 11, right?
Yeah.
All over what number? 2? Hold on one second, Alex. So x squared, what does this simplify to? Plus 4x
Minus 2.
minus 2 over 2.
And 2's
2's can't cancel. This is fine if you leave it like this. You could, if you want to say, okay, wait, I want to simplify even more. You could say this was y equals x squared over 2. And then what would happen? Plus what? Plus 2x. Then what? Minus 1. If you were to mathway this is what mathway would say. That's probably what WebAssign wants you to do. I am okay if you leave it as pink, if you leave it as white, if you go to green. I am fine.
You won't take off lines.
Now, like if you got to here and didn't simplify more there, yeah. But I'm okay with any of the above. Does that make sense? You guys all right? Okay, that's it. So how do you do your homework? Do you have to enter it into WebAssign? No, because like I just said, I'm okay with all 3 of those answers. WebAssign only wants it this way. I don't want you guys getting frustrated on I don't know how much more to simplify, whatever. My biggest thing is that you guys understand eliminating the parameter means to do what? Get rid of t. Yep. Okay, good.